about heart anatomy today. And before we go through the heart anatomy, we're going to look at 3 terms first. So over here, we have what we call heart rate, we have stroke volume, and we have cardiac output. So first of all, let's look at heart rate. So heart rate basically means how many times your heart actually beats in 1 minute. So how do we measure that? We use what we call beats per minute. Okay? For stroke volume, what it means is how much blood is being pumped in 1 beat. So that is what we call volume per beat. And when we talk about cardiac output, in short Q, we're talking about how much blood is being pumped in 1 minute. Next, we're going to look at an illustration of your heart. Now, this does not look like your heart that you probably see in a textbook, but this is basically made simple for you to understand how the blood actually moves through your heart. Now, if you look at your heart, there is 4 quadrants. We have the right side, we have the left side. The top part is known as the atrium, and the bottom part is known as the ventricle. So if I point this to you, you will easily know that this is known as your right atrium, and this is called your right ventricle. Same goes to this side, you have your left atrium and also your left ventricle. Now, the video is not flipped. When we talk about right and left, we are looking at someone's heart at a mirror view. So imagine yourself putting yourself on the wall, and you see that this side of your heart is actually your right side of your heart, and this side is actually your left side. Now, if you look at the different parts of your heart, there are a couple of blood vessels going in and out of your heart. As you can see that how it's being drawn, you will see that on the right side, it carries deoxygenated blood. So deoxygenated blood actually flows from your right atrium to your right ventricle, and you have oxygenated blood flowing from the left atrium to the left ventricle. Now, you realize that atrium is where your heart collects blood, and ventricle is where blood is actually pumped out of your heart. So if you look at the different blood vessels that you have, you generally have what we call veins and arteries. Veins generally carries deoxygenated blood, whereas arteries generally carries oxygenated blood. Another characteristic of veins is that they generally carry blood into the heart, whereas arteries carry blood out of the heart. So what you can see here is that from our body cells, once the body cells takes up all the oxygen from the blood, they will actually be transported back to the heart through the vena cava, which is a vein. It goes into the right atrium, then to the right ventricle, and is being pumped out through the pulmonary artery. So with this deoxygenated blood, your heart will pump it to your lungs, because there is where it's going to get the oxygen. And once it gets the oxygen, it's going to go back into the heart through the pulmonary veins, into the left atrium, to the left ventricle, and out from the aorta. Now, if you look at how blood actually flows through your heart, you can look from the right side. Now, you can see that over here, you can imagine blood having collected a lot of carbon dioxide, and now it's deoxygenated. It will carry into your heart through the vena cava so that it can be pumped out from the pulmonary artery to get to the lungs to expel the carbon dioxide and also to collect fresh oxygen. So once they collect fresh oxygen, they're going to come back into the heart through the pulmonary vein, into the left atrium, to the left ventricle, and then out from the aorta, and now it's going to go through everywhere else of the body. Now, once the blood exits the aorta, it's going to try to reach the tissue. So from there, basically, oxygen is being transported through the capillaries into the tissue. So this is when you can see this is basically your muscle, and you can see capillaries growing around the muscle, because that's how they actually get oxygen from the blood to enter the tissue. And at the same time, carbon dioxide will be transported into the blood so that it can actually go back to the heart. And the same process is going to repeat. Now, let's talk about acute adaptation, meaning what actually happens in a short period of time when you actually exercise. So what you're going to observe is that you will see that, number one, your heart rate is going to increase because your heart needs to pump more beats per minute to make sure that the oxygen supply to your muscles is sufficient. Next next thing you will see is that your stroke volume will also increase, because that's when your heart needs to beat harder to actually supply more blood per beat so that it allows more oxygen diffusion through your body. And finally, if heart rate increases followed by stroke volume increasing, you'll observe that the total volume of blood that is being pumped in 1 minute is going to increase. Now, that was short term, meaning when you're exercising, what actually immediately happens. We are talking about long term. That means you have been doing training, you've been training for a long time, and now what do you observe in your body? We call that chronic adaptation. So what you're going to be observing is that you will realize that your heart is going to get stronger. And when your heart gets stronger, one of the things that's going to happen is that you'll realize that at rest, your stroke volume is going to increase, because with your heart being stronger, every pump is going to give you a bit more blood. So when your stroke volume increases, in order to be more efficient, your body does not need to pump as many times, and therefore resulting in a decrease in the resting heart rate. So with that, you realize that your maximum cardiac output is going to increase. So with the increase of cardiac output, what you're going to be realizing is that your cardiac output times your oxygen extraction, that gives you your VO2 max, which is your maximum oxygen consumption. This will also increase, and that's what we want when we want to be fitter.